Hi, welcome back to educator.com and our series on the Java programming language. Today we're going to talk about arrays. First of all, what is an array? Arrays are used in most programming languages, and they're used as a variable object. And the special thing about an array is that it can hold not just one variable value, but multiple values. And in this array, all of the individual values are referred to as elements. Now, just like a table or a database, all of those elements are indexed by numbers. And so if you've got a string of data, the first element, the first data value in that string, we shouldn't call it a string because a string is a different type of data type, but in that list of values, the first value is indexed starting with a 0, so it goes from 0 on. And arrays are similar in concept to virtual tables, if you're familiar with any database technology. And as we're going to see here, there are two main types of arrays, and these are the single-dimensional and the two-dimensional. And think of single-dimensional, we'll call these 1D arrays. Think of single-dimensional arrays as a data list. Sometimes data will be stored in comma-separated values file. And we're going to see in the program when we get to a single-dimensional array, the values that you find in that single-dimensional array are enclosed in braces or curly Q brackets and then separated by commas. And so it's just a string of data. So those could be numbers, text, no matter whatever you want inside the array, any kind of value, especially character values. Now, when it comes to multi-dimensional arrays or two-dimensional arrays, this is more like a grid. This is more like a spreadsheet. So the data is ultimately going to be stored, and then you can print it and reference it just like you would any type of table in Word or a spreadsheet or a database application. So you've got columns and rows. That's why sometimes they call two-dimensional arrays an M by N array. And M refers to the number of rows, and N refers to the number of columns. So we've got, for example, we'll just label these M1 through 4, and N are our columns here. And so, for example, if we have a 4-row, 5-column array, that means that we've got 4 times 5 elements naturally that would lead to 20 different slots, if you will, for data storage. Now, in the code, you can declare an array a couple different ways. Again, one way for a single-dimensional array, and then a different variation on that for a multi-dimensional array or a 2D array. For our single-dimensional array here, we'll call this 1D, and our two-dimensional array. For a single-dimensional array, we will say we want an integer b, and then these are brackets. So whenever you see that symbol, it's really more like two open-close brackets right next to each other. And then we say, so the integer b open-close bracket equals a new integer, and then the number of elements we want in that string is between the brackets here, we're saying 100. So this particular way to declare a single-dimensional array will create an array that has 100 different slots or spaces for all of your values. Now, with a two-dimensional array, we set it up similarly, and we're going to name this array with a word here. So we say this array is going to be called totals, and we've got our open-close brackets again, but now notice how we have 2 of them. All right, so this sets up the M by N, the rows and the columns. And so we say we want the new integer, and then we want it to be 4 by 4. So that would lead to a 4-row, 4-column array, and that would naturally have 16 different slots for data storage. Now, when either of these arrays are initialized, just remember that by default, all of the elements have either null values if they're text string objects or text string values, data types, They're 0 if they're numbers, or they're false if they're Boolean values. Now, when you want to return data from an array, one really good, fast, easier way to do this is to use an enhanced, a different type of for statement, a different type of for loop. And the syntax looks like this. We still use the keyword for, and then we say, we're going to call this one number. And so we say all of the numbers in the array that's separated by a full colon, a dot dot colon, we're going to call this array my array. And then we say the total is going to be the total plus the number. And what that does is that statement would add all the numbers found in that array that we've called my array. And so whatever all those numbers strung together, if you add them all up, that would return, this statement would return that grand total. Now, keep in mind that this type of technique, this type of for statement, is used for obtaining or calculating array elements, or to loop through them, to iterate through them. If you want to change data, modify the elements, modify the values in the array, then you're going to have to use a traditional counter-controlled for loop that we've seen before in our loop chapter. But this, however, notice how retrieving data just returns the data and displays it. That does not change the data, nor does calculating the data. So this is very similar to a query in database concepts. So a query, there's a difference between a regular query that retrieves data, or a select query as it's called, and an action query, or a query that will modify values. This is very similar to a select query. We're just saying, go into this array, and if it's a two-dimensional array, we're saying go into this grid of data and pull out all of the data or some of the data. And if we want to calculate based on that data, we're still not changing the original values. We're just taking those values, performing a calculation, and then returning the result of that calculation. The original values stay intact and unmodified back in the array. Now, when we are using this data in a live program, we're going to be passing those values to the method, and then the method will handle all the math, or it'll handle all the display, or whatever we're doing with that data. There's two ways to pass data from an array to the method. There's pass by value and pass by reference. What happens with a pass by value is a copy of that data value, the element, is passed to the calling method. So the method in our program will refer to the array, get the data, and then do whatever it needs to do with it, display it, or do a calculation based off that data. Pass by reference, what happens is a pointer is passed to the calling method referencing the elements in that location, and then the data that's stored in the RAM memory at the time, that's where it can be ready for possible editing. So if an element that is being stored in the RAM memory at the time needs to change, it's going to be passed by reference. Now, by default, all arrays in Java are passed by value. All right, let's take a look at some of these arrays in our coding examples. All right, this first one we're going to look at here is a very simple array. And this is just to get you used to the syntax and what happens and how it looks when we run the program. So we start by just using our main statement, and then we set up our first array. We're going to have an array of integers, and we call this array array1, open close brackets there, and we say that we want this array1 to equal, in curly Q brackets, just 5 numbers, followed by our end statement, semicolon. So we separate the values by commas. We just say 1, 2, 3, 4, 5. And then we set up a for loop statement to display all of that data. So we say for the integer I, array1. So this is one of those enhanced for loop statements. And then we have the statement to do the work, system out print I. All right, so this is just setting up the array, 5 elements, print them out, and let's see what it looks like. All right, when we run this program, we call it simple array, and it just returns the values 1, 2, 3, 4, 5. So you can see how it works. Let's move on to something a little more complicated here. All right, in this example, This program is going to simulate rolling 2 six-sided dice, and we're going to do it 36,000 times. You're going to see there's, when it comes to dice, 36,000 will give us something around some nice even numbers. All right, so in a previous example, we saw that we rolled a single die 10,000 times, let's say. Here, we're going to make it a little more complicated. We're going to have an array that handles rolling 2 six-sided die and then storing the results of those rolls. So for this, we need to import our randomizer, our java.utility.random package, because we're going to use a random number generator for the randomness of rolling these dice. We're going to call this main class dice, and then we set up our method roll dice that's going to get called in our application later. We're going to set up a random number, and then we're going to set up variables for the first face of the first die, the second face of the second die, and then whatever our total is going to be. Now notice how we say we're going to have an integer, which is an array here, and that array is going to have 13 elements. Now if you know anything about probability, you should know that when you roll 2 dice, you've got 11 different possibilities, 2 through 12. So you can't roll a 1 and you can't roll anything over 12. It's just, it works out that, 1 1 is the lowest number that you can roll, and 2 6s is the highest number that you can roll, and all the numbers in between. So the question is, why do we set it up so that there's 13? Shouldn't there be 11? Well, the answer is that when you're randomizing from 0 to whatever number that you set up. So we're randomizing 13 because we want all 13 to be available, including 2 through 12. And then if we have the 0, so that's 0, 1, 2, 3, 4, and so on, all the way up to 12. So that's a total of 13. Now we're going to see later in this program that we say that we don't want anything that has a 0 or a 1. So we eliminate 0 and 1 so that we only get answers. We only get results that are 2 through 12. And we'll see how that's done a little bit lower in this program. First of all, we're going to initialize all our totals at 0. So we set up a for loop. We say we want the integer index to start as 0. We want that index as long as it's less than the total's length. And then we increment the index by 1 each time. And so we say totals, which is going to have the parameter of the index number, and that starts as 0. Then we set up another for loop to roll the 2 die. Roll the 2 dice. We say integer roll. We start with 1. We're going to roll it 36,000 times. And then we increment the number of rolls by 1 each time. For face 1, we say 1 plus whatever random number times up to 6, because it's a 6-sided die. Same thing for face 2. And then when we get our totals, we want to take the number that we get from face 1, whatever it happens to come up as, number that we get from face 2, and add them together. So if you get a 1 and a 3, it's going to add to 4, and so on. And then we're going to increment that each time we run these for loops. Then, once we've got all of our results, we're going to print them out to the user. We're going to show the sum of the 2 totals. We're going to show the frequency that they came up, and then the percentage of the total 36,000. And then we're going to say here in this statement, here's how we say we want to ignore any time a 0 or a 1 comes up in our randomization. So you don't have to do that with physical dice. With physical dice, you only got 6 sides. You're never going to get a 0. You're never going to get a 1. You're only going to get a 2 through 12. Here, when you randomize the 13 possibilities, sometimes it's going to come up as 0 or 1. So we say we loop through all of these for the integers. When it equals 2, we say k less than the total's length. So as long as if it ever comes up less than 2 or less, in other words 1 or 0, then we're going to leave those out. Then we say that we want to, for the percentage, we want to divide it by 360. That'll bring it down to a standard percentage number like 10, 20, or 30. Then we're going to print out our totals. All right, so this is the program that will handle the rolling of the die. Then we want to go to our simple application here, and that will set up a rolling mechanism. And this is the one that we're actually going to run when we get to our prompt. And we just identify the dice application that we set up in the previous file. And for each time we roll these dice, we're going to create a new dice application. We're going to call that application again. And inside the dice file, we had that application that we called roll dice. All right, let's see this in action when we run it. All right, so here, we are not going to run the dice program. We are going to run our roll program. And when we do, we see that we get our data values. We get the sum, we get the frequency, and we get the percentage. So the sum is 2 through 12, so we don't get the 0 or the 1. And notice what's happening with the 36,000. The numbers are all close to 7 is rolled the most, roughly 6,000 times. 8 and 6 are rolled approximately 5,000 times, and so on, all the way down to 2 and 12. So if you roll 2 dice 36,000 times, we get 2 and 12 coming up somewhere around 1,000 times. Let's try this again so you can see the randomizing factor. We run the roll program, and here again you can see 2 and 12 come up approximately 1,000 times. 3 and 11 come up around 2,000 times, and so on. All right, let me show you that one more time. All right, so you can see that as we roll these dice, so you're rolling the dice 36,000 times, and it's recording all of the outcomes, totaling them up, and then giving you the percentage. So out of the 36,000, 16% of the time, it came up 7, and 13 and 14. Notice how these numbers are very consistent as well. 2 and 12 come up 2% of the time in pretty much all of our examples. 3 and 11 come up 5% of the time in every trial run. All right, let me clear this, and we'll go on to our next example. All right, so we've got a staff of 4 people, and we've got products, 5 different products. We just have product numbers 1 through 5. We're going to get user import. We're going to get user input in this program, so we import the scanner package, and we're going to call this class sales. We call this method calculate sales. As we go down here, we've got a scanner input set up so that we can intake user input. Then we set up our arrays here. Now this is a different type of array. Notice how it's going to be a multi-dimensional array, a two-dimensional array. So we say this array sales has 2 sets of open close brackets. And don't get confused by saying double here. Double does not mean that it is going to be a 2-dimensional array. Double is the data type. We're using a double integer data type. And so we set up this 2-dimensional array with the values 5 and 4, and it's going to be a 5 by 4 multi-dimensional array. So 5 rows, 4 columns. Then we say to the user, enter the sales staff number, and that's going to be a number 1 through 4. And then if we want to quit the program, we have a sentinel in there that will allow -1 to quit the program. All right, and then we say while the person is not equal to -1, so as long as we're entering valid values, then go on to having the user enter a product number, and then have the user enter a sales amount, the total dollar value of what they sold that week. And then we set up an error checker here. And so we say that as long as the sales staff number is greater than or equal to 1, and it's less than 5, so in other words 1 through 4, same thing with the product 1 through 5, and it's not, and the amount is entered as a positive value, then we're okay. If any of those rules are violated, then we're going to give the user a data entry error message here. Say data entry error, enter the staff number. Staff number's got to be 1 through 4, and the product number has got to be 1 through 5. All right, so then we say enter staff number -1 to n after we've entered all that data. If we want to start over, we give the user the opportunity to enter the next sales staff number, and then we end the loop. All right, so then we set up the salesperson total. Now this is going to be with our output in our grid of results. And we set up the loop to display the table of the results. So we've got our columns and rows set up down here. And on our headers, we're going to list the product, the sales staff numbers, and what their total was. And then we use a for statement to loop through all those values and then display them, including adding up all the sales totals. So the product total is going to equal the product total plus whatever they've sold. All right, then when we go to all right, let's see this example running in our prompt. And we're going to run this program. We're going to say Java, and we called this one sales app to run. All right, so the first thing it prompts us is to enter the sales staff number. So I'm just going to enter some data here. We'll say that we're going to start with sales staff number 1. Product number 1, remember it's 1 through 4 for the staff number, 1 through 5 for the product. How much did we sell for that one? Let's say 100. All right, then let's stay with sales staff number 1 and product number 2 this time, and we'll keep it simple and we'll just say 200. And so let's say sales staff member number 1 sold some of all 5 products. Sales product 5, 500. All right, so we entered some data for all 5 products for sales staff member number 1. Now let's move on to sales staff member number 2. And we'll say that they sold some products here as well. And then let's move on to sales staff 3. And I'll just enter some random numbers here. All right, now let's say that we want to end the program. We hit -1, and so we can see our totals. All right, when we run this, notice how our output statements take all of that data, add them together where needed so that we can get our totals here, and then display that data in a grid. So we've got our product and sales staff members listed at the top. Their running total for each product, the running totals for each sales staff member, and then all of the individual data in the middle of the table. All right, let's see if our error checker traps an error and gives us a data entry error message. Let me clear this, and then let's run this program again. All right, so let's say that we enter a couple valid values. And then we enter a couple invalid values. So sales staff member, let's say 5. Remember, we only have 4. Product number 6. Sales amount. Aha. Now notice how it says data entry error. Enter staff number 1 through 4 only. Product 1 through 5 only. And so if you set up data entry error catchers, it should return a message that prompts the user on what they did wrong and how they can correct it. So we know that now we have to enter a staff number 1 through 4 and a product 1 through 5. All right, so let me say sales staff number 4, product number 3, and we'll end the program. And notice how it returns our grid of the valid data and the totals entered. And it's using an array to collect all this data, and then it's passing all the data back to the user in a grid. All right, let's clear this. And we will move on to our last example. And in this one, this is going to be the most complicated program we've looked at so far. And it's very good for an example of random number generation and using an array. And this is going to deal with a deck of cards, a standard deck of playing cards. And we're going to set up a series of 3 programs that is going to initialize the cards. It's going to then shuffle those cards in a random order, and then display all 52 cards in an array, in a grid, to the user, so you can see how every time you shuffle the cards, they are coming off the deck in a different order. All right, so first of all, we have to set up our card itself. So we're going to set up a class called card. We're going to set up a private variable that will only be used here in this program as the face and the suit of the cards. So the face value of the card, ace, deuce, 3, so forth, all the way up to jack, queen, king. And then the suit of the cards, hearts, diamonds, spades, clubs, so forth. All right, so then we're going to set up a constructor that initializes this card's face and suit. So we set up the public method card, and we are going to list the face value and the suit. And we set up the variables face and suit to mean card face and card suit. Then we're going to pass that to a string that will return a statement that lists for the user the face value and then the suit value. So it'll say ace of spades or king of diamonds and so forth. All right, then we are going to go to our program here that is going to compose the deck. So we call this class deck. We set up an array to hold all 52 card objects, card deck, open and close brackets, an index value for whatever the current card is, in other words, the card that's going to be on the top of the deck as we deal, and then the number of cards equaling 52. So we know that there's going to be a constant. We're always going to have 52 cards in the deck. And then the random number generator to randomly generate what the next card is going to be when we shuffle. All right, we set up a constructor to fill the deck of cards. We say, in this public deck method, we've got all of the faces, and then we have a single array, a single dimensional array for all of the face values, ace through king. That's what you see in the curly Q brackets here, separated by commas. Then we do the same thing, set up an array for all 4 suits, hearts, diamonds, clubs, and spades. And then as we go down here, we then create an array of card objects. So we say that the deck is equal to a new card with a parameter of the number of cards. What's the number of cards? 52. So we've already set that as a constant. The current card, when it gets initialized, is 0. And then as we deal cards, it will index them 1 through 52. Then we call our random number generator here to call each card as it comes up. Then we set up a for loop to populate the deck with all of those card objects. So we say the count starts at 0. The count is going to be less than, as long as the count is less than the deck length. The deck length is naturally going to be 52. Then as each card comes up, we want to increment the count by 1 until we reach 52, the deck length. And then each of the faces and the suits will come up as long as, there are 13 cards in each suit. So ace through king of hearts, ace through king of diamonds, and so forth. Then we're going to set up an algorithm to shuffle these cards to put them in the random order. So we call this method shuffle. And we're going to call this method in our shuffle application later. And so we start with the current card being 0. And then for each card, we're going to pick another random card and swap them. So as the first card comes up, then we're going to swap that with another random card and place that on top of it, and so on until we get a stack of cards that are placed in order at random. So we call the first card, and then we've got 51 cards left, naturally. So then we're going to select a random number between 0 and 51, and that is going to be the second card. And so on until we've got all 52 cards in a virtual, theoretical stack. And then we're going to continue on with this loop here first card, second card, so forth, until all of the cards are placed in a random order. Then we deal the cards. And so we set up a method called deal card. All right, then we deal the first card, and we've got our if-else statement here to return the current card and then move on to the next one right there. If we are done dealing, then we return a null value indicating all cards have been dealt, we've seen all 52 cards, and we're ready to shuffle again if we want to. All right, then the simple application to shuffle and deal these cards we call here shuffle up. And this is going to create a variable called myDeck, and this is going to be new, create a new deck every time we run this shuffle program. We've already set up the program called shuffle in the previous file to place all those cards in a random order. And here we're going to set up a loop to print all of those 52 cards in the order that they were dealt in the previous program. So we say, as long as it's each card and suit is less than 13, keep dealing all of them until we get all of the cards dealt in each of the 13 different possible face values. Then we set up a print statement to print a row of 4 cards 13 times until all of those cards are dealt. All right, so this will not only shuffle the cards, this series of 3 programs not only shuffles the cards, but then it displays them in the order that they were shuffled and in the order that they came up in a 4x13 grid of data. All right, let's see what happens when we run this program. Now, we don't have to run all 3. All we have to do is run the last one, the shuffle up program. That calls the deck program, which in turn calls the card program. So you got a series of methods that are sort of being called by each other here. So I'm going to say Java shuffle up. Notice that when we do, we get our 4x13 column here, set of columns, and we have all 52 cards. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we've got 4x13 equals 52. So all 52 cards are represented here, and they came up in random order. Let's run it again so you can see the randomization. So we started with the 3 of hearts and the 10 of clubs. We ended with the 5 of hearts. If I run it again, notice how the 7 of hearts and the queen of hearts came up first, and the 10 of clubs came up last. So you can see that as we run the shuffle up program, we get a different result each time. So this is a pretty complicated series of 3 programs here. So we've got the first program that initializes what the cards are, the second program that places them in a random order, and then the third program, shuffle up, that calls that shuffling program and then displays the results in a grid of data. All right, so in this lesson, we've learned about what arrays are. We've learned the difference between a one element or a one-dimensional array and a two-dimensional array. And then we've learned how to set up and initialize these arrays, populate them with data, and then display that data to a user in a grid form if we want to. All right, so next we're going to start talking about inheritance. That will be in Lesson 8. And thank you for watching educator.com.